All right, welcome to Notes 1-1. These are the exponent rules. And so the learning targets today are to develop basic exponent properties and simplify expressions involving exponents. And this is page 3 of your notes. All right, an iceberg is a large piece of freshwater ice that is broken off from a glacier or ice shelf and is floating in an open seawater. Icebergs are classified by size and shape. The smallest sized iceberg is called a growler. A growler was found floating in the ocean just off the shore of Greenland. Its volume above water was approximately 27 cubic meters. So above the water, right, the volume was about 27 cubic meters or meters cubed. Okay, so it says reason quantitatively. 2 icebergs float near this growler. One iceberg's volume is 3 to the 4th times greater than the growler. The second iceberg's volume is 2 to the 8th times greater than the growler. Which iceberg has the larger volume? Explain. So what we need to do is we need to figure out what is 3 to the 4th power. So that's 3 times 3 times 3 times 3. And it will be that much larger, right? It says it's that much times greater, so than the growler. And we have to figure out what's 2 to the 8th power. 1, 2, 3, 4, 5, 6, 7, 8 times 27. Now, since we're multiplying both by 27, really we just need to figure out which one is larger. 3 to the 4th. 3 to the 4th is, that's 9, 27. 27 times 3. 27 times 3 is 81 times 27 versus 2 to the 8th, which is 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128, times 2, I believe, is 256. I will double check on my calculator. Let me grab that, but I believe I'm correct. 2 to the 8th is 2. Up to the 8th power is 256. 3 to the 4th power is 81. All right, so I was correct. This iceberg, right, the 2 to the 8th times is going to be larger. Okay, next. What is the meaning of 3 to the 4th and 2 to the 8th? So I actually already did this, right? 3 to the 4th is 3 times 3 times 3 times 3. And 2 to the 8th, right, 2 to the 8th is 2 times 2 times 2 times 2 times 2 times 2 times 2, 1, 2, 3, 4, 5, 6, 7, 8 times. So rather than writing this, which it takes up a lot of room, we've got exponent notation. So it says, suppose the original growler's volume under the water is 9 times the volume of above. How much of the volume, or how much of the ice is below the surface? So it's 9 times the volume above. 9 times 27 is 9 times 27 is 243. It would be 243 meters cubed. It says, write your solution to item 3 using powers. Complete the equation below. Write the missing terms as a power of 3. All right, so what we've said is that 9 is the same thing as 3 times 3, and that would be 3 squared. And 27 is the same thing as 3 times 3 times 3. So it's 3 to the third power. And if I were to compress this into one equation, I would have 3 to the 1, 2, 3, 4, 5. This would be 3 to the fifth power. Off to the side here, they do talk about that the expression 3 to the fourth is a power. The base is 3 and the exponent is 4. So the term power may also refer to exponent. So we can use these words power or exponent, and they mean the same thing. So power or exponent means the same thing. All right. Look at the equation that you completed for item 4. What relationship do you notice between the exponents on the left-hand side, so these, the 3 to the second and the 3 to the third, and the exponent on the right-hand side? So what do you notice about these two exponents and their relationship to the 5? I'll give you a second to look at it. If you said that 2 plus 3 equals 5, you are correct. This is the relationship for when you're multiplying the same base, right? 3 and 3. You can't multiply different bases. But when you're multiplying the same base, you can simply add their exponents. All right, so we're going to see something like that on the back. Use the table below to verify the pattern that you noticed in item 5. First, write each product in the table in expanded form. Expanded form is when you're writing it out. And then express the product as a single power or a single exponent. The first one has been done for you. So they have 2 to the second, there's 2 to the second, 2 to the fourth, there's 2 to the fourth, and all together they have 2 to the sixth power. So we'll do the same thing. 5 to the third would be 5 times 5 times 5 times 5 to the second would be 5 times 5, and all together this would be 5 to the fifth power. You can do the same thing with variables. We've got x to the fourth. X to the fourth is x times x times x times x times x to the seventh. And all together that would be x to the 11th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And finally a to the 6th. And then a squared. All together, that would be a to the 8th power. Okay, express regularity in repeated reasoning based on the pattern you observed in the table in item 6. Write the missing exponents in the box below to complete the product of powers property. So this is the product of powers property. So when I multiply the same base, I will add their exponents. So this is a rule that we're going to use over and over and over again. Again, this is the power, the product property. The product property is that a to the m times a to the n equals a to the m plus n. That is the product property. It says use the product of powers property to write x to the 3/4 times x to the 5/4 as a single power. So x to the 3/4 times x to the 5/4. Well, we're multiplying the same base, so we are going to add those exponents, 3/4 plus 5/4. And when we add fractions, remember the bottom has to have the same denominator, but it already does. And then we only add the numerator, which is x to the 8/4. And 8/4 reduces, this is x to the second power, right? 4 goes into 8 twice, and 4 goes into 4 once, which is 2/1 or 2. The density of an iceberg is found by dividing its mass by its volume. So they're saying here is the formula for density, right? The formula is we're going to take the mass and divide it by its volume. Suppose a growler has a mass of 59,049 kilograms and a volume of 81 cubic meters. So we're going to plug this in right into D. It says it has a mass of 59,049 kilograms and a volume of 81 meters cubed. And we're going to divide those. Mass goes on top, 59,049 kilograms over 81 meters cubed. And our result is 59,049 divided by 81 is 729 kilograms per cubic meter. It says write your solution using powers of 9. Powers of 9. So we're going to rewrite the density is equal to 9 to the something power over 9 to the something power. Well, it's not 81 is equal to 9 times 9. So that's 9 squared. But 59,049, now I'm going to have to figure out how many times I'm multiplying by 9. I don't know. So to do that, on my calculator, I'm going to take 59,049 and divide it by 9. So that's once. Divide it by 9 again. That's twice. Divide it by 9 again. That's 3 times. Divide it by 9 again. That's 4 times. Divide it by 9 again, and I get down to a 1. So I believe that this is 9 to the 5th power. So we're going to verify it. 9 to the 5th power is 59,049. All right, so this is 9 to the 5th. And our result, oh, I shouldn't have put D here. My result, I'll do it off to the side, was that my 9 to the 5th over 9 to the 2nd, I ended up with 729. 729 is 9 to the 3rd power. Right, you can check that. 9 to the 3rd power is 729. What pattern do you notice in this equation? What pattern do you notice here? So what do you notice about the exponents on the left-hand side and the exponent on the right-hand side? I'll give you a second to think about it. If you said that 5 minus 2 is equal to 3, you are correct. And so when you're dividing the same base and they have exponents, this is the subtraction property. It makes sense if you think about it. If you multiply, you're going to add the exponents, and then this is called the division property. When we divide the same base, a and a, a to the m and a to the n, we're going to subtract. It's going to be a to the m minus n. Now you do need to be careful. It's always numerator first, denominator second. So these are two big properties that we're going to be using over and over and over again. And let's go ahead to the next page. So page 5. It says, use the table below to help verify patterns you notice from item 11. First, write each quotient in the table below in expanded form. Then express the quotient as a single power of the given base. The first one has been done for you. So they had 2 to the 5th over 2 to the 2nd. And then what happens is that each of these reduce out to a 1. And they're left with 2 to the 3rd power. We're going to do the same thing. 5 to the 8th. Over 5 to the 6th. And what ends up happening is that these 5s reduce, and we're left with 5 to the 2nd power. We can do the same thing with variables. We have a to the third over a to the first. Those reduce, and we're left with a to the second. And finally, right, we have x to the seventh over x to the third, and these will reduce, 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 and we're left with x to the fourth power. So based on these observations, they want us to write the quotient or division property. So the quotient property is a to the m over a to the n equals a to the m minus n. And they said where a cannot equal 0, and that is because you cannot divide by 0. So they're making that note. All right. It says use the quotient of powers property, or I just call it the division property, to rewrite this as a single power. So we have a to the 11 over 3 over a to the 2 over 3. And so what's going to happen is that we have a to the 11 over 3 minus 2 over 3. Now, they already have a common denominator, so when you're adding or subtracting, you would have to get a common denominator, but we already have one. And then remember, we only subtract our numerators. So this is a to the 11 minus 2 is 9 over 3. And 9 over 3, 3 goes into both. 3 goes into itself once and into 9 3 times. This is a to the third power. All right, so the product and quotient properties can be used to simplify expressions. Now, we have this expression. I'm going to write it off to the side. We have 2x to the fifth times 5x to the fourth. Now, something that students do, a common error, is they'll think that they need to distribute. But remember, distributing is only over addition or subtraction. I don't see any addition or subtraction. So we're only multiplying coefficients, so the 2 times 5, and we're going to multiply our like variables. So x to the fifth times x to the fourth. And this is 10, x to the 5 plus 4, which is 10, x to the 9th power. All right, let's flip it over. And give us a second example. We're going to do the quotient property. So we have 2x to the fifth, y to the fourth, over xy squared. All right, so this is the 2 only has a 1 to divide with, so it's just 2. We have x to the, we're going to remember that if there's no exponent written, we're going to put an exponent of a 1. This is 5 minus 1. And this is y to the 4 minus 2, which is 2x to the fourth y squared. Another way some students like to see this done is rather than using this rule, right? If you ever forget the rule, I'm going to go back and do these examples a second way. If you forget the rule, you can always multiply, write them out in expanded form. 1, 2, 3, 4, 5 x's, and then we have times 5, and then x to the fourth. So again, I'm giving you another method. A lot of students will start switching rules around or confusing them or forgetting them. And here I can see, I can multiply 2 times 5, which is 10. And I have x to the 1, 2, 3, 4, 5, 6, 7, 8, 9, x to the 9th power. We're going to do that same method on this side with this example. So in the numerator, I have 2 x to the fifth, y to the fourth, over, in my denominator, I have x, y squared. And I will reduce out things that are common. And I'm left with 2 in the numerator, and 1, 2, 3, 4 x's, so x to the fourth, and 1, 2 y's, y squared. And the denominator has simplified to a 1. All right, we're going to do the try these. We're going to try each expression for simplifying. So A, it says 4xy to the 4th times negative 2x squared y to the 5th. I always like to group my coefficients together. So I've got negative 2 times positive 4. My x's, I have x to the, don't forget it's a first, right? So x to the 1 plus 2. And y to the 4 plus 5. So this is going to be negative 8, x to the 3rd, and y to the 9th. Again, you can expand this out if you'd like. If you expanded it out, you'd have 4xy to the 4th times negative 2x squared y to the 5th. And then group your like items. That would be negative 8, x to the 1, 2, 3, y to the 4 plus 5 more is y to the 9th. I'm going to do try these B. Try these B says 2a to the 2nd, b to the 5th, c over 4ab squared c. All right, so to do this one, I'm going to group my constants together. That's 2 over 4. This is a to the, don't forget there's a little 1 on there, a to the 2 minus 1, b to the 5 minus 2, and c to the 1 minus 1. Now this is interesting, right? C to the 0 power, well, can you picture c over c? What does that become if I had c over c? C over c is just 1. And so c to the 0 power is the same thing as 1. All right, moving down here, that's 1/2, right? 2 goes into itself once, 2 goes into that 4 twice. And then a to the 2 minus 1 is 1, b to the 3rd, c to the 0. Whenever you have c to the 0, you can just get rid of it because c to the 0 power is like multiplying by 1. Multiplying by 1 won't change this, so our answer is 1/2 a b to the 3rd. All right, and our last one, I'll do down here, C. I have 6y to the 3rd over 18x times 2xy. Now I'm going to put that as a fraction. When we're multiplying fractions, we multiply straight across. If you want to simplify your fraction before you begin, you can as well. I'm just going to multiply straight across, so that's 6 times 2, and then y to the, there's no other x's, so it's just x to the 1st, and y to the 3, y to the 3 plus 1y right here over 18x. Now, these x's can reduce out, and also 6 times 2 is 12, so I have 12 in the numerator, y to the 4th power, 3 plus 1, over 18. And then they do have a common factor. 6 will go into both. And 6 goes into 12 2 times. And 6 goes into 18 3 times. This is 2y over 3. This can also be written as 2/3 y. They're both equivalent. So I'm going to write it as 2y over 3. Again, I'm going to do this a second way so you can see another method. If I have something like 6y to the 3rd over 18x times 2xy, I can write my numerator in one fraction. So that's 2 times 6 times x times y times y times y times y, right? 3 y's here and 1 there, over 18x. These will reduce. That gives me 12y to the 4th over 18. Find their common factor, which is 6. Divide both the top and bottom by 6. And you get 2y to the 4th over 3. Oops. I dropped my y to the 4th. Ah, right here. I apologize. That should have been a y to the 4th. All right, we're going to do the check your understanding. So the first check your understanding, number 15. Number 15 says simplify. So number 15, simplify 3yz squared times 5y squared z. I'm going to group my coefficients together. So that's 3 times 5. I'll group my y's. Don't forget that's a y to the 1st. So I have y to the 1st times y to the 2nd. And I have z to the 2nd and a z to the 1st. So z to the 2nd and z to the 1st. This is 15 y to the 1 plus 2, z to the 2 plus 1, which is 15 y to the 3rd, z to the 3rd. Again, you can, if you want to, expand this whole thing out to reiterate this property. Number 16, simplify 21f squared g to the 7 over 4 over 7fg to the 3 over 4. So I'll group my coefficients, I'll group my f's, and I'll group my g's. 21 divided by 7. 7 goes into both of these. 7 goes into 21 3 times and into 7 once, so I don't need to put over 1. This is f to the 2 minus 1 and g to the 7 over 4 minus 3 over 4. This is 3f to the 1st, g to the, we already have a common denominator, so that's 7 minus 3, which is 4 over 4. 4 over 4 is 1, so this is 3fg. Okay, and finally, they have a word problem. It says a growler has a mass of 243 kilograms and a volume of 27 cubic meters. So the growler has a mass of 243 kilograms and a volume of 27 cubic meters. I'm going to go back and look at that formula once more. Right. Density equals mass over volume. It says to compute the density of the iceberg by completing the following, and to write your answer using powers of 3. So they want us to rewrite this as, this is 3 to the 5th power. This is 3 to the 3rd power. So our density will be our mass over our volume, which is 3 to the 5 minus 3, or 3 to the 2nd. And it says to leave it as a power of 3. All right, guys, I hope you enjoyed the notes and you took good notes. I will see you on Tuesday.